Yes, I am here. Did you calculate?
What the squeeze theorem is saying is pretty obvious. Here's an example. Cartman runs as fast or faster than Kyle always on any given day. Cartman runs as slow or slower than Kenny always on any given day. Now, if Kyle runs 2 miles an hour and if Kenny also runs 2 miles an hour, then how fast is Cartman running? Well, it's pretty obvious that Cartman would also be running 2 miles an hour. This is because squeeze theorem essentially says that if I'm always greater than or equal to one thing, and if I'm always less than or equal to another thing at some point, and those two things are equal, then I must be equal to whatever those things are equal to. I've kind of been squeezed in between them. In other words, for all x in an open interval containing c, except possibly at c itself, and if the limit as x approaches c of the function h of x equals L, which also equals the limit as x approaches c of the function g of x, then the limit as x approaches c of the function g of x exists and is equal to L. We can see this graphically. We can see h of x approaching c, and we can see g of x also approaching c. And since f of x is in between the two functions, then we know that the limit of f of x exists, according to the squeeze theorem. Also take notice that all of the functions approach c and not that they necessarily have to equal c. Let's try it numerically. Here's the problem. The point of the problem is to see if there is a limit of f of x as x approaches c. Now, c is 0, so we have to test each function in terms as x approaching 0. So we do that, and we see that as the limit as x approaches 0, the x squareds go to 0. So then we are left with 4 is less than or equal to the limit as x approaches 0 of f of x, which is less than or equal to 4. Therefore, we can conclude that the limit as x approaches 0 of f of x equals 4, because of the squeeze theorem. Now, there are a couple common mistakes that people make. They assume that there has to be a value at c. However, this is not true. This is about the limit as x approaches c, which means that a value at c is not necessary, although it may occur.
Okay, let's all take out our math homework and go over the problems.
Math homework, where did I find